2020 National Electrical Code (NEC) does not require arc fault circuit interrupter (AFCI) protection for the outlet at the vanity in a bathroom that is separated from a bedroom by a wall without a door or with a doorway that is at least 36 inches wide and as high as the ceiling. NEC 210.12 A1 requires AFCI protection for all 120 volt, 15 amp and 20 amp branch circuits that supply outlets or devices installed in dwelling unit bedrooms. However, NEC 210.12 A2 exempts bathrooms from this requirement. The NEC does not require AFCI protection for bathrooms because bathrooms are considered to be wet locations and AFCI devices are not designed to operate reliably in wet locations. If the doorway between the bedroom and bathroom has a header, then the bathroom is considered to be a separate room, and the outlet at the vanity would not be required to be AFCI protected. AFCI protection is a critical safety feature designed to prevent electrical fires. It works by detecting arc faults, which are dangerous electrical discharges that can occur when insulation on wires becomes damaged or frayed. These arc faults can generate intense heat and ignite surrounding materials, leading to fires. AFCI devices are designed to quickly interrupt the circuit when an arc fault is detected, thereby preventing a fire from starting. Ground fault circuit interrupters, or GFCIs, are another important safety device that protects against electrical shock. GFCIs work by monitoring the current flowing in the hot and neutral wires of a circuit. If there is a difference in current between these two wires, it indicates that current is leaking to ground, which could be through a person touching a live wire. The GFCI quickly interrupts the circuit, preventing a potentially fatal electrical shock. Bathrooms are considered wet locations due to the presence of water from sinks, showers, and bathtubs. Electrical devices and wiring in wet locations are more susceptible to corrosion and damage, which can increase the risk of electrical shock and fire. Therefore, the NEC has specific requirements for electrical installations in bathrooms to ensure safety. One of these requirements is the use of GFCIs for all receptacles within a certain distance of sinks, showers, and bathtubs. GFCIs are designed to protect against electrical shock in wet locations, while AFCIs are designed to protect against electrical fires. While both devices are important for electrical safety, they serve different purposes and are not interchangeable. In the case of a bathroom that is separated from a bedroom by a wall without a door, or with a doorway that is at least 36 inches wide and as high as the ceiling, the NEC does not require AFCI protection for the outlet at the vanity. This is because the bathroom is considered to be a separate room from the bedroom, and the AFCI protection requirement only applies to bedrooms. However, it is important to note that the NEC does require GFCI protection for all receptacles within a certain distance of sinks and bathrooms. Therefore, the outlet at the vanity in the bathroom would still need to be GFCI protected, even if it is not required to be AFCI protected. If the doorway between the bedroom and bathroom has a header, then the bathroom is considered to be a separate room, and the outlet at the vanity would not be required to be AFCI protected. A header is a structural element that supports the weight of a wall above a doorway or window. When a doorway has a header, it creates a clear separation between the two rooms, and the bathroom is considered to be a separate room for electrical code purposes. In summary, the NEC does not require AFCI protection for the outlet at the vanity in a bathroom that is separated from a bedroom by a wall without a door, or with a doorway that is at least 36 inches wide and as high as the ceiling. However, the NEC does require GFCI protection for all receptacles within a certain distance of sinks and bathrooms. If the doorway between the bedroom and bathroom has a header, then the bathroom is considered to be a separate room, and the outlet at the vanity would not be required to be AFCI protected. Understanding the specific requirements of the NEC is essential for ensuring electrical safety in your home. If you are unsure about any of the electrical code requirements, it is always best to consult with a qualified electrician. They can help you ensure that your electrical system is installed correctly and meets all applicable safety standards. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest NEC requirements to ensure that your electrical system is safe and compliant. Electrical safety is a critical aspect of home ownership. By understanding the basics of electrical safety and following the NEC requirements, you can help protect yourself and your family from electrical shock and fire. Remember, when in doubt, consult with a qualified electrician. They have the knowledge and experience to ensure that your electrical system is safe and compliant with all applicable codes and regulations. Also remember, local codes may vary from the NEC and could be more stringent. Check with your local jurisdiction for specific requirements. Furthermore, always energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as insulated gloves and safety glasses. Never work on electrical systems while standing in water or on a wet surface. If you are not comfortable working with electricity, always hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. Here are some additional points to consider regarding AFCI and GFCI protection. Firstly, AFCI protection is typically required for circuits that serve bedrooms, living rooms, dining rooms, and other areas where people are likely to be sleeping or spending a lot of time. This is because these areas are considered to be high-risk areas for electrical fires. Secondly, GFCI protection is typically required for circuits that serve bathrooms, kitchens, garages, and other areas where there is a high risk of electrical shock. This is because these areas are considered to be wet locations. Thirdly, it is important to use the correct type of AFCI or GFCI device for the specific application. There are different types of AFCI and GFCI devices available, and each type is designed for a specific purpose. Finally, it is important to test AFCI and GFCI devices regularly to ensure that they are working properly. These devices should be tested at least once a month. If an AFCI or GFCI device fails to trip when tested, it should be replaced immediately. By following these tips, you can help ensure that your electrical system is safe and compliant with all applicable codes and regulations. Electrical safety is a shared responsibility. By working together, we can help prevent electrical shock and fire. Always be aware of the potential hazards of electricity and take all necessary precautions to protect yourself and others. In addition to the NEC requirements, there may be other local codes or regulations that apply to electrical installations in your area. It is important to check with your local building department to determine what specific requirements apply to your project. When planning an electrical project, it is always best to start by creating a detailed plan. This plan should include a list of all the materials you will need, a diagram of the electrical circuits, and a schedule for completing the work. Having a detailed plan will help you stay organized and ensure that the project is completed safely and efficiently. Before starting any electrical work, it is important to obtain all necessary permits. In most cases, you will need to obtain a permit from your local building department. Obtaining a permit will ensure that the work is inspected by a qualified electrical inspector and that it meets all applicable codes and regulations. When working with electricity, it is important to use the right tools for the job. Use insulated tools that are specifically designed for working with electricity. These tools will help protect you from electrical shock. Always inspect your tools before each use to make sure they are in good condition. If you find any damaged or worn tools, replace them immediately. When connecting wires, it is important to use the correct type of wire connectors. Use wire connectors that are rated for the size and type of wire you are using. Make sure the wire connectors are properly tightened to ensure secure connection. Loose wire connections can cause electrical fires. When installing electrical boxes, make sure they are properly grounded. Grounding the electrical boxes will help protect you from electrical shock. Use a grounding wire to connect the electrical box to the grounding system. When installing receptacles, make sure they are properly wired. The hot wire should be connected to the brass screw, the neutral wire should be connected to the silver screw, and the grounding wire should be connected to the green screw. Incorrectly wired receptacles can cause electrical shock and fire. When installing lighting fixtures, make sure they are properly supported. Use a mounting bracket that is designed for the weight and type of lighting fixture you are installing. Make sure the mounting bracket is securely attached to the wall or ceiling. When working in a confined space, be sure to provide adequate ventilation. Working in a confined space with poor ventilation can lead to a buildup of dangerous fumes. Open windows and doors to provide fresh air. When working with electricity, it is important to stay focused and avoid distractions. Distractions can lead to mistakes that can cause electrical shock and fire. Turn off your cell phone and avoid talking to others while you are working. If you need to take a break, step away from the work area and clear your head. When you are finished working with electricity, be sure to clean up your work area. Remove any debris or materials that could be a fire hazard. Store your tools in a safe place. Electrical safety is an ongoing process. By following these tips and staying informed about the latest electrical codes and regulations, you can help protect yourself and your family from electrical shock and fire. Always remember that electricity can be dangerous, and it is important to take all necessary precautions. If you are ever unsure about something, consult with a qualified electrician.